Okay, now here is the variable view, okay, and this is the data view. In the variable view, you can see that these are variable names. What is important with them? We cannot have spaces, and we cannot use characters like this and sign, this and sign here. It's not possible. If I write anything, it will variable name contains an illegal character. It's not possible. And I cannot write it like that. Space K is not okay. With if I can have if I have this empty space, it's not possible. Or if I have and, it's not possible. It's a variable name contains an illegal character. Okay, so all these are defined, the type as numeric, and this is the width. And decimals, the decimal points, the numbers after dot, and you can see that these are grouped. Clear, present. Okay, this is a tumor. They can be good or bad in tests, as a result of tests in human beings' body. They can be good or bad. Absent, present. Okay, so these are different things that you can find, and whether they are present or absent, we group them. And here, not elevated, elevated, and these are the other groups, not elevated, elevated. You can see it here. So let us continue. These are scales. It says these are scales. We are going to decide whether they are correct or not. Okay, these are defined as scale. This is defined as nominal. Okay, I started. Okay, so you can see here that this A and 1, okay, it's either present or not present. So it's 0 is okay for me, 0 or 1. I don't need to write it as 1.0. Let's look again here. So here, 0 or 1.0. Why it's not necessary to write it absent, present, absent, present. We are just grouping it, okay? So too many numbers will mix our minds. We don't need it. We need just one present, 0 absent. That is enough. The simpler, the better. Here, okay? So this is 0.00. It's not good writing this way. And here again, all this stuff, it seems complex when I see it. 2 decimal spaces here. Certainly not necessary. Look here, not elevated, elevated. This is just grouping. And when grouping, just 1 or 0 is enough. You don't need decimal spaces. So how you can correct this? I go to variable view and I come here, okay, these decimals. I don't need any decimals for grouping. So I delete these decimals, make them 0. I come here now, look, they look better, okay? This stuff is confusing enough, okay? It's a very serious case, whether they are present or not, and the measurements, whatever it is. And with all this, I don't need to make it, I shouldn't make it more complex. Just 0 and 1. When I'm grouping anything, 0 or 1. Here, this is a research study that I take from internet. When they are grouping it, they didn't know how to change it. That's why that they didn't know how to correct it. Here, you see, they didn't know how to correct this one to 0, okay? So they didn't want to make it wrong, but they didn't know how to change it. That's why that it seemed like that. But now it's better. Look here, just clear. I click this A and 1, clear, clear, clear. Absent, present, okay, that's better. I click again, okay, it's simple. Good. Yes, what else I can interpret and I can see from this data set? This is a data set, by the way, and this data set's name is right in here. You can see here tumor 544 .sub is the extension of this SPSS document. Okay. Now hospital names here. You see here, hospitals, okay. There are numbers, it says nominal, but it doesn't write the hospital names. So when you see this, it is grouped, okay. It says it's grouped, but there's again missing value here. Look here, it is nominal, okay. So if it were text, let us see here. If it were string, for example, okay, look to the symbol. There's a small a here, and you should write hospital name, okay. But here it said, okay, I'm going to group it. Okay, let us group it. I write numeric, and when you are grouping anything, let us look how many group numbers. It says that there is this 5, 6, you know, that's 9. Okay, it seems like that there are 9 hospitals. Okay, there are 9 hospitals. So it is only 1 digit number. So that's why that I'm grouping it as 1, 0, and label hospital names. So this is important for output also, and for remembering what's going on here. So always you should have a label when you put a research study, save it somewhere and look again 1 month after it, you will forget what it is exactly. For example, okay, it is hospital, but these other measurements, what are they, what they stand for, you will forget them. So always write label or some, if you write variable names, reminders, write some reminders that you will recall after time what's going on. For example, this tumor, it can be anything else, okay? These are tumors in human body, so you should write what it represents here. Hospital name, okay. Just a moment, hospital name. And here it is, okay. So there are 9 hospitals. So what is the other thing missing here? 1 hospital A, or whatever it is, or, the name of the hospital, okay? So the second, the name of the other hospital. Hospital names are missing here. Hospital B. Okay, so I will not correct it, all of them. So there should be 9. Why there should be 9? Because there are 9 hospitals. So if I return, I will see hospital names. If I click A and 1, I should be able to see hospital names here. Okay, so the other definitions, let us look to the other definitions, whether they are true or not. We are discussing now, there is a data set in front of me that I found from internet, okay, whether it is defined correctly or not. This is what I am checking. Okay, so here, let us go to the beginning. Pet K. The first missing thing is the label, what it stands for. It should be, there should be, this is missing, so someone else may interpret it in a different way. So let us check whether width and decimals are okay. Width is width. Width is the how many characters you have here, okay? How many numbers. So let us look 1, 2, 3, 4, 5, 6, okay? The highest one, let us look 1, 2, 3, 4, 5, 6. Okay, it seems like the highest number is 6 digits, okay? So maybe you can write it 7, but it's 11 is a lot. There's no need for it. So for understanding, okay, 7 is enough. So, but if you write 6, let us see what happens if you write 6, or if you write maybe 4. Okay, if you write it less, it will not, it writes this time, but it is the first time that you want to write it, it will not allow you. It's not correct. So you have to at least write one greater number. Okay, so here Lindell Hospital, let us look what it is. Here, this is a measurement. It says that it is the scale, but it is, we cannot see what it stands for. Label is missing. Here label is missing. So in all the research studies you have, it's good writing, okay? So the results may not be affected when calculating, but people may interpret it wrongly because the variable names, it should be clear what it stands for. Okay, so these have decimal numbers, you see. For example, 1, 2, 3, 4. There are 4 decimal numbers here. And this is, width is 5. How do we know that? We don't count the dots, by the way, here. This is 1, 2, 3, 4, 5. Width is 5. And here 1, 2, 3, 4. This is 4. A decimal is 4, width is 5. It seems like that in all the other ones. So this is named host. Let us see. Okay, decimal 4, width is 5. We may have one more. This is how we write it. And labels, it's good writing them. Just a reminder and explaining what these variable names are here. Yes, this is how we define them. I don't know how many here patients are there. To find that, we have to find frequencies. Okay, I'm going to ask it to you. Record again. So here it's from analyze descriptive statistics frequencies. Okay, so frequency, the number. I'm going to find the number. I pass everything to the right side. So it's from analyze frequencies. I want you to know it from analyze frequencies. I'm recording this session also. This is okay. I click OK and I'm going to see the output. Where is my output? Here. Okay. So I see that I have 544 patients. Okay. And I see that I have no missing variables here. That's what a frequency table shows me. The frequency in hospital A, there are 33 patients. This 4, okay, we explained that it is missing. So since when we have labels, okay, we see it here. For 4, we didn't have labels. Let us look to 4. We didn't have any labels. Yes, here, hospital, okay. So I didn't define what is 4, what is 3. So it is just written 4. Or I don't have any labels here, so output, it doesn't have any explanations, okay? So if I had any labels instead of this variable name, it will show me a detailed explanation. And in the frequency tables I have, here you can see the frequencies and percentages. Now, we are going to find whether scales are normal distribution or not. How we can find them? First of all, let us look what were the measurements. The measurements, here, the measurements, you can see that I have lint host and SQ host and reduc 10. These are measurements. Let us see whether they are normal distributions or not, okay? So for that, I go to frequencies again, but I'm going to use histogram. So I don't need all the other ones. I'm going to pass everything to the other side. And here I take lint host, I take PET-K. PET-K is here. Okay, but it's also measurement. I can also have it. I can test whether, yes, this one, all these scales, I can take all these scales here and this one. Okay, these are all the scales. You can see that they are rulers, by the way. And okay, sorry, I find frequencies. Before saying okay, I have to go to charts and look to the histogram, and I will say show normal curve on histogram, continue. Okay, and I should have charts soon. Let me see. Yes, okay, this is good. You see that this looks like a normal distribution. When you have this normality curve here, the histogram shows you that it is normal distribution. It's good. We can use parametric test with this. We can use reliable test with lead host. It shows normal distribution. And today we are going to learn what are these parameters. Look here. This is not a normal distribution, okay? We have some value here and some value here. So path K is not a normal distribution. And this one, it goes to the right. So it is right skewed. So these are outliers. We have some outliers. If we omit this patient, sometimes it is possible in research studies, we omit these patients. We take them out of the study because they have some special cases, okay? Maybe they are too young, all the others are above 50, and these two patients are very young, let us say 15 years old, and maybe they will affect the results. So this we will omit them from our research study and take all the other group and try test a medicine with them. The biggest aim of our research studies, biostatistics, is finding a good way, a good medicine to cure diseases, problems in human health, and to make them better, or tumors, making them smaller. Here you can see that this is left skewed. This is left skewed, so we can omit some patients from here, again from this side. Maybe these patients are in the very bad case and they have very low blood pressure, so it's why that they are here, so we can omit them. All the others are here, so we can take these in our research studies. So with this one we cannot have a parametric test because it's not normal distribution. This is left skewed, it is negatively skewed, this one, and this one we cannot take a normal, we cannot take a parametric test because it's not normal. But if we delete some patients from here, if we omit them, and instead of, let us say, a 544, if we have maybe 514, by choosing which patients make our curve like this, then we can have with the rest will be normal distribution, and we can have our research study with them, because we have to find a solution to health problems. But with this one we have to do nothing. It's just, you can see it's a normal distribution.